Hello, welcome to LeetCode Solver, and today we are going to solve 29th problem in 30-day lead coding challenge, and the problem name is binary tree maximum path sum. Well, let me read the problem first. Binary tree maximum path sum. Given a non-empty binary tree, okay, find the maximum path sum. For this problem, a path is defined as any sequence of nodes from some starting node to any node in the tree along the parent-child connections. Well, the path must contain at least one node, and does not need to go through the root. Okay, we have to find maximum path sum. Well, the value can be negative as well. Okay, this is interesting. So, and we have to find a path which could, which may not include root. I mean, path is simply any any uh, sequence of nodes in between two nodes. And if the problem is if it is not in binary tree, like the given input is like just a array, then problem is simply the problem which was asked in first week of lead coding challenge, which was maximum sum. You just have to maintain the summation. Whenever you get negative, then you will turn into 0, and then after start summing again. And yeah, that was the basic maximum path sum problem in linear array. But if it is in a binary tree, then we have to think about how we can approach this problem. Well, there can be cases like if uh, we have to take at least one node. So if there exist negative values, every nodes contain negative values, then the answer could be negative as well. So this is one case that we should handle in maximum path sum problem. Well, if we have to take at least one node, then answer can be negative as well. Now let's think about how we can solve this problem. So basically we can approach this problem recursively using depth first search, where we will do a recursion and I mean a recursive solution where we will just see what is the maximum path sum to this left child as well as to right child maximum path sum, and I mean linear maximum path sum to left child and right child. I mean taking only considering only one linear path. So then if we get linear path sum, like we can, in that case we can calculate the path which goes from left to right as well. So we will calculate that if we know this, and if we know same for this, like linear uh, linear path sum, then we can find a path sum for this chain, which will be basically, if a linear path sum of this is positive, then we can take. If it is negative, then no need to take it. And same applies here. And finally we'll find the uh, chain, like taking both left, right, and current node, like kind of chain path sum. If we, and every steps we calculate that chain path sum as well as the linear path sum for the particular node, then we can maximize whenever we do such calculation, like finding linear uh, path sum as well as this circular or whatever it kind of considering the both left, right, and current node for every nodes. If we calculate these all things in every access of the node, like while doing recursion, we will access every node and we will access left child and right child and calculate the linear path sum for left child and linear path sum for right child. And after calculating this recursively, we will now consider maximizing the answer. And yeah, in this way we can find out the solution to this problem. Well, let's think about time complexity. The time complexity would be basically linear, as we will be doing recursion and accessing one node only once, and then after accessing, we will after having getting the results from recursion to left child and right child, we will doing a simple calculation to maximize, which will be also in O of one of operations. So overall, the complexity will be big O of n, where n is the size of the node of the tree. Well, let's go for implementation. So let's also give some example, like let's consider the example. Here we see this is 20 and linear path sum for this is 15 because it is positive and we are considering this, and for this also we are considering this linear path sum is 15 and linear path sum is 7, and we can calculate the uh, total path sum considering this node, like chain path sum will be 7 plus 5 plus 20, which is the answer to this problem. And now this node itself will return to the parent, like while doing recursion it will have to return to the parent. So it will return to the parent not this 42, but it will return to the parent the current node's value and the maximum among these two, which is 15. So it will return to its parent 15, but after doing this it will kind of like returning will be 35 to this node, but um, performing while solving the problem to this subtree, it will performing these chain linear path sum operations as well and maximizing the answer. So in order to do that, we have to pass either we have to keep track of a global variable and try to maximize that global variable in every recursive steps, and or we can pass a variable as a reference and we can try to maximize that. In C++, we can pass a variable as a reference to a recursive function, and finally we will retrieve that uh, value after performing recursive operation when recursive operation finish. So let's try to do that. Well, we can either maintain a extra global variable which will be our answer to the problem, so which is basically maximum path sum. So let's say maximum path sum, we basically maintain maximum path sum initially 0, and now we will perform recursion. We can perform recursion over here, which is basically return the linear path sum. So say maximum path sum helper or linear path sum, whatever maximum path sum helper, and it will take tree node as an argument, and recursion finish if root base case for the recursion is root is null. not let's say root is null, then like if it gives calls to some its left and right child which are null, so in that case they will simply return 0. Now we will calculate linear path sum left linear path sum. Left linear path sum will be equals to maximum path sum helper root left. We give recursive calls there, and let's find the right linear. This is the linear path sum. Max path sum helper root right. Now we have both linear path sum. Now let's find the circular path sum, I mean chain path sum, which is our chain path sum. We have to maintain a chain starting from current, which will include current value, say root value, and if left is not negative, then we will take left. If left linear path sum is greater than 0, then take that. Then chain path sum, we will take that. Also, if right is also positive, then we will non-negative, we can take that as well. Right linear path sum is greater than 0, then we can take this. There is no harm if on taking non-negative value, because it will increase our path sum. Right linear path sum. Well, we have this now, and let's try to maximize max path sum, which is equal to maximum of max path sum and this value, chain path sum. Well, now let's try to return the linear path sum, which is basically we have to return the maximum. We have to take the maximum in between left and right and do the sum with the current one. If max between left and right is non-negative, then we will take them, otherwise we will just simply return current value. So if let's find max linear path sum, so max linear path sum will be maximum among left and right, left linear path sum and right linear path sum. Well, if this max linear path sum is greater than 0, then we will return this max linear path sum plus current node value, otherwise we will simply return current node value. Because if both values, like this is -15, this is -7, then in that case I have to return 20 because it is positive. Because if I maximize both of them, I will get negative. So if this is get a positive, then after I will take. Otherwise, I will just simply return current node value in order to maximize path sum. Well, let's compile the problem. Before that, let's give call to this method from here as a root, and let's return max path sum variable, which is stored in our class. So let's make max path sum variable at 0 initially, so we don't have to initialize here. So let's run and see comparison error or whatever. Yes, comparison error on declare identify max linear path sum. Okay, at line number 27, max linear path sum. We haven't declared this according to compilation message. Yes, you are absolutely right. There was another message as well. Okay, good. Let's try with test cases. It's so difficult to provide test cases for the tree in this platform. Wow. Well, this is the same. So answer should be 42. Yeah. Let's try with different. Whatever. 8, 15. Then answer should be, let's try with -8. Answer should still be 42. Yes. Let's try with -15. As I mentioned in problem, like if everything is minus, then I have to take this 20, and 20 will be the answer. And yes, and I have another case in my mind. If this is 20, this is 9, so I want to take whole and make bigger. If I take whole these things, it will be like 29 minus 10, 19. So instead of 9, if I put it like 11, then it will take this tree subtree, this chain as a answer. It should take 20 plus 20 minus 10, which is negative. So what is 20 minus 10? 10. And I mean, which is lesser than 20, but it is not negative. So 10 plus 11, which is 21. So answer should be 21. Yes, let's submit the problem. -3. Okay, yeah. So I was thinking about this. I told the case that we should take negative, but I forgot to initialize. Let's initialize it as int min, so that we can get negative value as an answer as well. So let's submit. Well, accepted. Let's see what is the time. 36 millisecond and 28.4 megabyte memory. Okay. Well, as I mentioned before, the time and space complexity both are big of n, where n is total nodes in binary tree. And instead of maintaining this extra global variable, we can solve it passing over here as well. Let's do that. We can do it quickly. What we have to do is we just in C++ we can just pass it as a reference. So let's pass it as a reference, and yeah, Okay, well, let's define over here. Yeah, I think it should work. Finish. Let's submit. Yes. Well, the difference is like instead of putting a global variable outside of the, we just pass this parameter as a reference. So it will be updated every time globally. So finally, whatever we are getting over here will be the answer. Well, I just noticed that the the tree is not a normal tree, it is always a binary tree. So the space complexity will be instead of big O of n will be the time complexity as we are accessing every node, and space complexity would be big O of log of n. So this is space complexity. And above one, this one is time complexity. Okay, thank you so much for watching this video, and if you have any comment or any alternative approach or anything else, please feel free to comment. And yeah, have a nice day.